Hi everyone, we will discuss about some definition of the Kmap. That is, first is implicants. What is this implicant means? Implicant is a product or min term in sum of product or sum and max term in product of sum. In a Boolean function, if you take as one example, suppose we are taking one example like y is equal to a, b, plus AC plus BC. Some example if you take here, it is in the form of SOP. So in this implicant is whatever the product term. AB is a product term, so it is one implicant, and AC is another product term, so it is another one implicants, and BC is another product term, so this is also implicant. So in this example, AB, AC and BC are the implicants. If you take example of POS, something like that, y is equal to A bar plus B into A plus B bar into B plus C bar. This is one example here we are taken. In this POS, some term is called as an implicant. So, A bar plus P is the one implicant and A plus B bar is another implicant. Same way, B plus C bar is the another one implicant. So, in the simple definition, implicant depending upon which type. If it is SOP type, all product term is known as implicant. If it is POS type, then all sum term known as a implicant. In implicant, we have major 4 types. One by one, we can discuss. The first type is prime implicant. What is this prime implicant means? A group of square or rectangle made up of bunch of adjacent minterm which is allowed by the definition of a Kmap are usually known as prime implicants. It is also defined as a PI. In simple way, we can say that all possible group, whatever we formed in the Kmap, that is known as prime. Suppose we will take one example here. Suppose here in this example, we have present 1 in these cases 0, 1, 5, 7. This is the example taken. In this, how much prime implicant we have? The one group possible here is we can make 0 and 1 one group, and another group is 5 and 7. One more group possible, that is 1 and 5. But when you simplifying this group, usually we are not take according to the overlap rules. But when you are taking as a prime implicant all possible groups. So in this, the 0, 1 is a group 1 and 1, 5 is group 2 and 5, 7 is group 3. So in this particular example, we have prime implicant, we are calling as a PI as a 3. Similar way, we can do it another one implicant type, that is called essential prime implicant. These are those subgroups, or we can call subgroup of the prime implicant which cover at least one minterm that cannot be covered by any other prime. This is also known as EPI. These simply we can say that those prime implicant which always appear in final solution. Suppose we will take same example previous what we have taken. In that example we have taken 0, 1 and 5, 7, 1 is present. In this, the 0 and 1 we are making as a grouping and 5 and 7 we are making as a grouping. And these two we are calling as a essential prime implicant. Usually when you are minimizing and Kmap, this 1 and 5 usually we are not taking. Why? Because this is overlap and there is no single one which is present here. Both the one are present some group. So this is not considered when you are simplifying Kmap. So this group is removed in this essential. So essential prime implicant, we have only 2 particular group here. That is simple way we can say that those prime implicant which always appear in final solution. That means according to the Kmap rules, the overlap rules and other rules, whichever we are considering as a group, that group only we are considered as a essential prime implicant. It is a subgroup of the prime implicant. Next, one more method we have called as a redundant The prime implicant for which each of its minterm is covered by some essential prime implicant are usually known as redundant prime implicant. This is also known as RPI. In simple way, we can say that this prime implicant never appears in final solution. It is also a subgroup, and the group of redundant prime implicant plus previous essential prime implicant together we are calling as a prime implicant. So whichever we are not taken in the essential prime implicant, that portion we are calling as a redundant prime. If you take the same example as previous, which is 1 present, 0, 1 and 5, 7. In this, the prime implicant never appears in final solution. So that usually we will make this is one group and this is one group. And the another group, whatever we are taking 1 and 5, we are not considering in the final. But this is known as RPI, or it is known as redundant prime implicant. So the combination of RPI and these already we discussed. 0, 1 is a essential prime implicant and 5 and 7 also essential prime implicant. So combination or a total of essential prime implicant plus RPI usually known as a prime implicant. So the prime implicant has a two type. Mainly one is essential prime implicant, another one is redundant. Both are subgroup. Essential means whichever final appears. Redundant means whichever not appears. Together we called all the EPI and RPI together, it is a prime. One more interesting prime implicant we have, that is called as a selective prime implicant. The prime implicants for which are neither essential nor redundant prime implicant are called selective prime implicant. These are also known as non-essential prime implicants. They may appear in some solution or may not appear in some solution. This is somehow interesting, and this is usually possible in Kmap. There is a two possibility of mapping. See, if I take one example which is present 0, 1 and also present 5, 7, 6. In this case, what are the group possible? Usually, we know that we can do 0, 1 group possible. One more, I can do 5, 7 group possible. One more, we can do it as a 6, 7 group, right? This is the 3 group usually we can do as a final group. But here, the one more group is possible, that is already we know that we can take in 1 and 5. Now here, in this, the particular group, one important thing is there that we can take either this group or this group as a one single group. That means we will take two combination here. First combination check here. If it is 1, 1 and the 5, 7, 6 is 1 present, I will do some grouping, something like this is one group and this is another group and this is one group. This is the one type of Kmap I can do it. These are the 3 group possible. That is the group of 0 and 1 and group of 5, 7 and group of 6, 7. Okay, this is one type of the Kmap group. Once again, check it out. Another possibility there in this group. What is that possibility? Considering same example, if it is 1, in this case, I can also take as a something group like that. This is the one group, 0, 1 group, and 6, 7, I will make it group, and one more group. Instead of 5, 7, I can do group on 5, 1 also. So in this case, what is my group is called? It is either the group of 0, 1s and 1, 5 and it is 6, 7. Okay, this is entirely different from previous group what we are used. So in this example, we can say that the particular part either we can use this 5, 7 or we can use 1, 5. Any one is possible. Anyway, 0, 1 and 6, 7 is common in both the group. The difference is either we can do 1, 5 or 5, 7. This two we are calling as a selective prime implicant. That means some solution we may not have this option, but some solution we may have option that either we can select one 5 group or 5 7 group, either we can select one type or either we can say another type. This particular portion we are calling as a selective prime implicant. Either we can select 1 5 also a correct answer, and if you select as a 5 7 also a correct answer. We can see some example of Kmap and how much prime implicant and essential prime implicant, redundant prime implicant and selective prime implicant present in these examples. First examples, these 1 5 6 7 11 12 13 15. In this example, how much prime implicant we have? First, prime implicant means all the possibility here possible. So usually in prime implicant we can do that it is one possibility, I can do something like that. Another possibility we can do something like that. One more possibility we can do 7 and 6 and 15 and 11. Also possibility is there that we can do these four group 5 7 15 30. So in this we can call that prime implicant is group is this one group and this is second group and 7 6 is third group and 11 15 is fourth group and 12 13 is fifth group. So these are 5 group possible as a prime implicant. Now how much essential prime implicant usually required? So essential prime implicant, whatever we are done, this portion that is 5, 7 and 13, 15, this 4 not required. Why? Because this is there is no single ones present here. So these reasons we cannot use this one. So essential prime implicant we will take only the 1, 3, 4, 5 these portions, and second group we are ignoring in the essential prime implicant. And what is redundant prime implicant? Usually the combination of essential and redundant I will get together. So in essential 2 is missing, so obviously that is redundant prime implicant. So redundant prime implicant is that which is the we are using that not used in the final equation. So 5 7 13 15 is not using final equation. So RPI is only one group. And last one, selective prime implicant. So here there is no SPI possible here. So SPI is 0. The final answer of each one, the PI is possible in this, the 5, and EPI is 4 and RPI is 1 and SPI is 0. In this grouping, this is usually required, this and this. These are called as a essential prime implicant, must and should require. Other implicant, something like selective, either I can select the combination of something like this. See, I can take the combination one side, I can take 15 14 and one more is 5 7. This is the one possibility we can do. Okay. If you do like this possibility, these two called as a selective option. And one more possibility, instead of this 5 7, I can use as a 1 5 also possible, can do as a 1 5 also possible like this, and 7 15 also possible. Okay, so these four we are calling as a selective prime implicant. So what are selective? Either I can take 1 5 as a one group and 7 15 as another group. This is also possible in the group. Anyway, the red mark is compulsory. One more, the portion what we are taken, either we can take 15 14 as a one group and one more we can call as a 5 7 as a group. So these four we can calling as a selective prime implicant. Either I can select this portion also possible or either I can take this portion also possible. Okay, and essential is the red mark whatever, the 0 1 and 14 10. Essential prime implicant is 2 and SPI is possible 4 and prime implicant already we discussed. Let's take example of 0 4 5 7 10 11 13 and 15. In this example, first we can do all the possibility of grouping here. So first grouping possible, usually we can do this 4 number, this 10 and 11 possible, and 0 4 possible, same way 5 4 possible, and 15 11 possible. In this we can say the group number 1 is 0 and 4 we are done. Then we are done such a way that 5 7 13 and 15. Then we are done 11 and 10, and also we are done 4 and 5, and also we are done 11 and 10, 11 and 15. In this grouping we have to check that these are total prime implicant. So total number of group possible, that is prime implicant. So we can easily say that the prime implicant in this Kmap is 5. Now this we have to make sure that how much EPI, how much RPI, and how much SPI we have to get. Already I told that the summation of EPI, RPI, SPI is equal to prime implicant. So these three are subgroup of the prime implicant. So what is the rules for essential prime implicant? The rules that the individual one number of groups or cells that is not there in any group. If you check here 0, it is not there in any other 4 group. So this group we are calling as a essential group. Again, if you go for 5 is already there in other group. Go to 7 is not there in any other group. So this is also called as a essential group. Same way, check cell number 11 is already there. Then go for cell 10 is not there in any of these groups. So again this is essential group. Now if you go for 4 and 5, listen carefully. The 4 is already there in one essential group, and 5 also there in one essential group. So both the cells in the group are there in essential. So this group is called as a RPI. So this is nothing but redundant prime implicant where each cell belongs to some essential group. So nothing unique, not present in any particular group. So if you go for 11 and 15, 11 is already there in this essential group, and 15 also there in this essential group. So both are present. So this group is again known as redundant prime implicant, RPI. So from this way we can say that in this total 5 prime implicant we have PI is 5 and ESI is 3 and RPI is, so total 5 we have. So selective prime implicant is not required here. Now go to the another example. In this example, if you see, we are getting as a 0 is 1, 4 is 1, 5 is 1, 10 is 1, 11 is 1, 13 is 1, 15 1. This is similar to this one, only 7 cell is not 1. All other are same. Now how to do the group for this? We can do the group of 0 and 4. We can do the group of 4 and 5. We can do the group of 5 and 3. We can do the group of 13 and 15. We can do the group of 15 and 11. We can do the group of 10 and 11. So total how many group here possible? So we can do 0 and 4 one group, and 4 and 5 another group, then 5 and 13 another group, and 13 15 one group, and 15 11 one group, and 11 and 10 group. In this first you have to find which one is essential group. First if you take 0, it is not present in any of this group. So this is we can call essential. So that the cell that is not containing any of group, that particular cell is known as essential group. Now go to the 4 and 5. See, 4 is already present in one group and 5 also present. But 5 present, which one is essential or not, we don't know. If it is both the cell is essential, then only we can call as a RPI, redundant prime implicant. Okay, let's leave that one and go for 5 and 13. 5 also there in one group, 13 also there in one group, but we don't know these two are essential or not. So again leave it to next one, 13 and 15. 13 is one group and 15 is another group, and we don't know these two group are essential or not. So leave that one also. Then go 15 and 11. 15 is one group and 11 is another group, and we don't know which are essential. So leave that and go to 11 and 10. Here 11 is already there in one group and 10 is not there in any group. So
this group is again essential. Okay. So from all these 6 groups, we decided that we have 2 essential groups. So if any group contain both these essential cells, then it is called RPI. But when you go to 4 and 5, 4 is essential, but 5 is not an essential group. So if any such a group that one is essential or is not belongs to both the cell are essential, and both the cell is contain another group, not essential group. So that group is usually called as a selective prime implicant. Okay, that is called SPI. So 5 is present in one group, but this is not an essential. 4 is essential group. So such a group is known as SPI. The difference between RPI and SPI is RPI previous, here check it out, the 11 and 15, 11 is present here, 15 is present here, both are essential group. So if any number of cells, all cells present in essential group, then it is RPI. If all cells in present in other group but non-essential group, that is called SPI. Okay, that is called selective prime implicant. So 13 and 15, both are present. 13 is one selective, 15 also another. These both are not essential. So these are selective prime implicant. So summary of these implicant, listen carefully. Prime implicant means all possibility. Essential prime implicant means any one cell is not belongs to any group. RPI means each cell belongs to essential prime implicant. SPI means each cell not belongs to ESI but belongs to other group. So like this we can make as a PI, EPI, RPI and SPI.